how do we determine if this equation that we're looking at is representing a directly proportional relationship? Real quick, remember that when we were looking at a graph, we said a proportional relationship was any graph that showed a straight line, and we had the y-axis and we had the x-axis. And we also looked at tables to determine if a relationship that was shown in a table was a directly proportional relationship. And you know, we're used to seeing all of our stats put into it like this, and we went through and we did our thing to determine if it was proportional or not. Now, instead of looking at graphs, okay, and instead of looking at tables, we're going to be looking at equations. And so here's the equation right here. And just like where the graphs and the tables both had x and y in them, our equations are going to have x and y in them. So let's clean this off, and this is what we do. First off, you need to make a little table that you can just put over here. A little T table, if you're doing it at home, would work like this. Here's your x's and here's your y's, and then you could just list your statistics like that. What we need to do is that we need to test what would happen. If we knew what x was, we could figure out what y is. And so put in just some very easy small numbers. I recommend maybe using 0, 1, and 2, but you could use any number that you want to. And this is what you do with these numbers. You choose these, make sure they're small, okay? Make sure those x values are small so that way you don't need a calculator most likely. And then you come over here. This is y, this is 2, and this 2 is multiplying the x. Well, here we said x was 0, so plug in 0 and figure out what it equals. 2 times 0 is 0, so y equals 0, and I plug that in here. Then we come back through and we do the exact same thing. Y equals 2 times x. Well, x is 1 this time, and 2 times 1 is 2. So you put 2 in here. Now what this is telling us is that when this x value is 0, the y value is 0. But when this x value is 1, the y value is 2. So when the x value is 2, let's go plug that in and find out what that is. When this x value is 2, we know that the y value becomes 4. And now that we have a table, we can go through and check to see if it's directly proportional or not. This one up by 2, and this one up by 1. So our ratio of change, or our slope, is 2 over 1. And again, we see that it went up by 2 again, so plus 2. And it went up by 1, so plus 1. So 2 over 1 again. Yes, it's proportional. Now, let's look at another equation that's a little bit more advanced, but it's the same idea. Is this equation representing a proportional relationship? Does this x directly change how this y behaves? Well, let's get our chart in here. Let's plug in some small numbers for x, and let's just go and check it. And now we're ready to go. Y equals -3 times the x value. This time we're saying x is 0, so let's plug a 0 right in here, and then it adds 5 to it. So -3 times 0 is 0, and 0 plus 5 is 5. Okay, so let's go and do that again. Y equals -3 times, in this case, 1 plus 5. So -3 times 1 is -3, and -3 plus 5 is +2. And I'm sorry, I forgot to put this 5 right in here. When the x value is 0, the y is 5. So x is 0, y is 5. X is 1, y is 2. And one more. This time the x value is +2. And we get -6 when we multiply these two numbers together. And now we can add 5 to it, which makes it -1. So let's go and check our table and see what we get. Well, this is going down by 3, so that's -3. and this is going up by 1, so that's plus 1. So we get a rate of change of -3/1. Let's try that again and see if we get the same rate of change. That's going down by 3, and this is going up by 1 again. So yes, it is proportional.